Hi, and welcome to the DRO Pro segment on installing a magnetic digital readout kit onto a milling machine. This video is the second of a 4-part series and shows you step by step how to install a magnetic scale onto the x-axis of your mill. Now, if you haven't seen the previous video, I would suggest watching it now because each video builds on the previous segment's material. All right. So let's get back to our mill and install the x-axis scale. And usually it's a pretty easy installation. Normally the x-axis scale simply mounts to the back of the table. So let's have a closer look. So here we are at the back of the table, and typically the x-axis scale mounts right on the back of the table right about here. And it moves back and forth along with the table movement. The reed head is stationary and mounts on top of the scale and is held in place with a bracket secured to the saddle like this. But one thing I noticed right away is that the x-axis scale is definitely longer than what I really need it to be. And I don't want the scale to stick out past the end of the table. But now remember, magnetic scales can be easily cut to length, so we'll go ahead and do that in just a few minutes. But first, let's have a look at what it's going to take to mount the y-axis scale. Now the y-axis is pretty much the opposite of the x-axis. For the y-axis, the scale is going to be held stationary while the reed head moves back and forth. Let's take a closer look. So the y-axis scale will mount very well right about here on the base of the mill. And the reed head will be installed using these two 90-degree brackets mounted to the back of the saddle right about here. Like that. And since we have plenty of room on the base here to mount the y-axis scale, there's really no reason to cut it any shorter. But there's no doubt the x-axis scale is a little bit too long. So next, let's take a look at what it takes to cut a scale. So we first need to go to the library page on the DRO Pro's website and download the Cutting Scales Worksheet 2-Axis Mill. And this is what the worksheet looks like. Now, the first item the worksheet asks for is the x-axis travel, meaning the full travel of the x-axis. You may have recalled earlier we measured this to be 13.5 inches, so let's go ahead and fill that in. Next, we need to find max length. This is the maximum length scale that would conveniently fit in our mounting area, or in this case, on the back of the table. And it looks like we've got around 20.25 inches of room to mount the scale. So let's go ahead and fill that in for max length. Now, moving down the worksheet, our x-axis travel is 13.5 inches. And then we'll need to add 4 inches to that, which means x-min will be 17.5 inches. The next line calculates x-max. From above, our max length is 20.25 inches. So we'll subtract 3/4 of an inch from that, which means x-max is 19.5 inches long. All right, so that finishes the math. So next, we need to prep the scale. First, we transcribe the hash marks from the stainless steel strip over to the shoulder of the scale. Next, we remove the cap screws from the opposite end of the scale. We take the end cap off and then slide out the stainless steel strip. So now we mark the scale according to the worksheet. Now notice that we're marking these distances from the cap end of the scale down here to include the cap length itself. And one other point, on our library page we have a document called How to Cut Magnetic Scales, which covers all of this in a lot more detail. And of course, if you ever get stuck, you can always call us at DRO Pros. Remember, you're the customer and we're here to help you. Alright, so the shortest we want to cut the scale is X-min, which we calculated to be 17.5 inches. Let's go ahead and mark that in red. And the longest we want the scale, X max, is 19.5 inches. Let's go ahead and mark that in green. So here we've got the marked scale. The shortest we want to cut the scale is marked here in red. The longest we want to cut the scale is marked here in green. So cutting anywhere between the two marks is fine, but remember, DRO Pros always recommends cutting longer over cutting shorter. And remember, you can always cut the scale shorter, but you can't cut the scale longer. Now, an important point to remember is to never cut a scale shorter than the red mark or X-min. In most cases like ours, the red mark is shorter than the green mark, but it is possible to have these marks reversed on some of the smaller size mills. Again, the bottom line to remember is to never cut a scale shorter than the red mark. So now we're ready for the fun part, cutting the scale. All right, let's start cutting. All right, so now we can start to reassemble the scale. The first thing we need to do is to reinsert the stainless steel strip, making sure to insert the hash mark end first so that the hash marks on the stainless steel strip line up with the marks we made earlier on the shoulder of the scale. Next, we'll mark the end of the stainless steel strip where we need to cut it. Slide it out a bit, and then trim it off. Then we'll slide it back in and test fit the end cap. And finally, the holes for the end cap screws are already there because the holes are actually the preformed grooves or slots that are part of the extrusion or scale body. All we really need to do now is simply tap the hole. So to do that, we'll use an M3 by 0.5 plug tap. So to prep the scale, the first thing I'm going to do is to remove the stainless steel strip. So with the tapping done, we'll put the stainless steel strip back in. Making sure the hash marks, again, line up. We'll bolt on the end cap. So finally, here's our finished custom length x-axis scale. Now for the y-axis scale, we'll leave that to stock length because as we saw before, it fits well within the mill's base where we'll be mounting it. So there's really no reason to cut it any shorter. All right, so at this point, both of our scales are ready to go. But before we start drilling holes, we need to make sure that everything fits together and the reed head won't run into the end of the scale. In other words, we need to do a test fitting. But in order to do that, I'll need to temporarily hold the scale and the reed head in place. So how do I do that? Well, here's another best kept secret of mounting digital readouts. It's Scotch brand double-sided outdoor mounting tape. Now, don't let this stuff fool you. This tape is seriously heavy duty and you're warned ahead of time to not use too much. Trust me, find or roll this stuff and you'll be impressed. All right, so in order to mount the x-axis scale, I first need to locate the box that reads Simple Mounting Kit on the outside. Inside the box, we find the reed head mounting bracket and also the M4 by 20 millimeter socket head cap screws, which bolt this bracket to the saddle of our mill. Now, going back to the kit box, I next need to find the X-axis scale box, and inside that there are several bags within bags, and we need to open them up until we find the one that looks like this, labeled scale mounting hardware. Inside this one, we'll find 4 black socket head cap screws. The shorter 2 are M4 by 16 millimeter and are used to fasten the scale to the table. But for now, we need to find the longer 2 black screws, which are the M4 by 20 millimeter. The longer 20 millimeter screws are used to fasten the reed head to the mounting bracket here that we just looked at. So let's go ahead and get the M4 by 20 millimeter screws out of the bag and fasten the reed head to the mounting bracket. And next, we'll put some of the Scotch mounting tape to the side of the bracket. And then I'll apply 2 1-inch strips to the back of the X-axis scale. Okay, so here we are at the back of our mill. Let's take a look where everything's going to mount. The scale is going to mount on the back of the table right about here, and the reed head bracket will mount right on the center of the saddle right about there. All right, now the first thing that catches my eye here is that the reed head appears to be sitting a little bit higher than I want it to. Basically, if the reed head sits this high, it also forces me to mount the scale higher on the back of the table because I need to position the reed head in the middle of the scale so it doesn't hit the inside edges. But I also need to remember that I have to leave enough room on the top of the scale here to mount the scale cover. And we'll take a better look at that a little bit later on. But for right now, I could probably get away with mounting everything as is, but I really want to demonstrate the absolute best quality mounting job for this video. So for this situation, I want the reed head to sit a little bit lower. So to make that happen, I need to shorten the height of the reed head mounting bracket, probably by about 1/8 of an inch or so. All right, so here we are with a modified bracket on the right and an unmodified bracket on the left. And you can see that the top surface of the modified bracket is a little bit shorter than the unmodified bracket on the left. And all we did was to mill the top side off a bit so the installed height of the reed head would sit a little bit lower. So let's go ahead and reassemble everything and put it back on our mill. All right, so here we are back at the mill, and you can see the reed head sits a little bit lower now which also means that the scale sits a little bit lower. And that gives us the room we need later for mounting the scale cover. All right, looks like everything fits pretty well. So next, let's go ahead and run the x-axis back and forth and make sure the read head doesn't hit the end of the scale with the table moved all the way to either side. So we can see here that the read head is approaching the end of the scale. So now that we've hit the stop, we can see that there's a little over a 1-inch gap between the read head and the end of the scale. And that's exactly what we want, is to have some extra scale on each end so that we don't crash the read head. So this side checks good, but let's run the table to the other side and make sure we've got clearance on both ends. All right, so if we take a look here, we can see we're getting pretty close to the end of the scale. And if we look a little bit closer, we can see that we offset the read head mounting bracket a little bit to the left of the saddle. Now, we had quite a bit of clearance on the right-hand side of the scale, so to get a little bit more clearance on the left-hand side, let's go ahead and move the read head mounting bracket over towards the right a little bit. Okay, so we've repositioned the read head. Let's go ahead and run the table all the way to the stop. All right, so now with repositioning the read head, you can see that the clearance between the read head and the end of the scale is now good. And that's one of the advantages of using this exterior mounting tape, is you can reposition things and make sure that all the clearances are correct. So with that done on the left side, let's go ahead and recheck the right side of the table. All right, so now we've moved the table back to the left stop now, and we can still see a gap between the end of the read head and the end of the scale. And that's the real advantage of using this double-sided tape, is that it allows us to check the clearances before we start drilling our holes. Now, one other comment. It doesn't really matter how much extra scale is left over on either end. All that matters is that the read head doesn't hit the end. Whether your clearance ends up being 0.5 millimeter or 3 inches is irrelevant. As long as the read head doesn't hit the end is all that matters. All right, so now that we know where the scale and read head are going to be mounted, we need to center punch the holes. All right, so that should do it. So next, let's remove the scale and the read head assembly. So next, we'll drill the pilot holes for the scale. Now, the kit comes with metric hardware, But if you wanted to use standard bolts to mount the components instead of metric, that would be fine too. But we'll be using what came with the kit. So for the first step is to drill the pilot holes for tapping. The scale mounts to the table using 4mm socket head bolts. So for the pilot holes, we need to use a 3.3mm drill. Alright, and so for the reed head mounting bracket, it mounts using 6mm bolts, which require a 5mm pilot hole. So we'll go ahead and drill those out now. Alright, so with all of our pilot holes completed, now we need to start tapping. Now we've drilled 4 blind holes, meaning the hole does not pass all the way through the material. This is important because it affects the type of tap we need to start with. We'll start by using a plug tap, and then second, we'll finish the hole with a bottom tap. Let's go ahead and take a look at the differences between these two. Now, if you look closely at the tap end, you can see a plug tap in front here is tapered at the end, where the bottom tap behind here is square and is not nearly as tapered towards the end. This is because the bottom tap is threaded almost all the way to the end because it's designed to tap the very bottom threads of a hole. The taper on the plug tap in front here is important because it does two things. First, because the thread is tapered and gradual, it's easier to start threads with. But perhaps more importantly, because of its taper, it's also easier to control what angle the threads first start at. Now this is extremely important when starting to tap. It's imperative to make sure that the tap starts threading at exactly the same angle as you drilled your pilot hole. Having a tap break because it didn't go in the same angle as your hole is not a pleasant experience. And finally, when you're tapping, take your time. Go in until you feel the tap start to clog with chips, and then occasionally remember to back it out to clear the tap. Alright, so getting back to the scale end cap holes, we'll start with the M4 by 0.7 plug tap in front, and then we'll finish the hole with the M4 by 0.7 bottom tap. And again, it's different from the plug tap because it has threads almost all the way to the bottom. Alright, so first we'll start tapping with the plug tap. And now we'll finish the hole off with the bottom tap. And as expected, this is initially going in nice and easy. The only threads it's really going to be tapping will be the threads towards the bottom of the hole, since we've already done most of the work with the plug tap. Now we'll start the other end with the plug tap. And then we'll finish it off with the bottom tap. Okay, so now I've finished tapping both holes for mounting the scale. So next, let's tap the holes for the reed head bracket. We'll start by tapping both holes with the M6 by 1.0 plug tap, and second, we'll finish both holes off with the M6 by 1.0 bottom tap. So first we start with the plug tap. And now we'll finish both holes off with the bottom tap. Alright, so now that all the holes for the x-axis are drilled and tapped, let's go ahead and mount the scale and the reed head. But remember, in order for the reed head to work correctly, we need to make sure that the hash marks on the scale and the hash marks on the reed head end up on the same side when they're both mounted. So let's take the scale and the reed head over to our mill and have a closer look at this. Now the first priority that I want to think about is which way I want the reed head cable to be routed. Personally, I like the X and the Y axis reed head cables to be routed on opposite sides so they don't get tangled. Since the Y axis is going to be over here on the left side of the mill, I want to run the X axis cable over to the right side. So with the cable from the X axis reed head going to the right, the hash mark on the reed head ends up being on the top side, as we can see here. So all we need to do is to mount the scale with the same orientation. So in this case, we need to mount the scale like this, with the hash mark on top over here like this. And this is the same reference mark that we saw earlier when we were cutting the scales. So this is how I want to mount the scale, with the hash mark over here on the top of the scale. But what if I needed to mount the reed head with a cable going to the left, which would cause the hash marks on the reed head to end up on the underside of the reed head? Well, that would be okay too. I'd simply mount the reed head as I wanted to with the cable going over the left, and then all I'd have to do is to simply flip the scale so that the hash marks were also now on the bottom side. The point is to match the orientation of the reed head and the orientation of this scale so that they match. Okay, so now that we've figured out how everything's going to fit together, let's go ahead and mount it. We'll start with the scale, which mounts using the M4 by 16 millimeter socket head cap screws. Next, we'll install the reed head and the support bracket assembly, which installs using the 6 millimeter socket head cap screws. And don't forget, before you install the reed head support bracket, make sure to install the 4 grub screws. Now, besides helping to level the bracket, the grub screws also help to easily set the distance or the gap between the reed head and the scale. Now, so far we haven't really leveled the scale. All we've done is to pretty much just eyeball what we think is approximately level. So to make sure that everything is truly dialed in, next I'm going to set up my dial indicator on the saddle and rest the tip of the dial indicator on the top shoulder of the scale along here. All right, so now that the dial indicator is set up, I'll simply run the table back and forth, left to right, and adjust the end of the scale either up or down until the dial indicator zeroes out. Okay, so you can see there that the dial indicator, the value decreased a little bit, but overall that's not really too bad at all. I'll go ahead and bring the table back a little bit so I can get access to the end cap screw. I'll loosen it, and then I'll bring this end of the scale a little bit up to bring the dial indicator value back to 0. All right, so I moved the table a little bit just to give me access to the end cap screw. I loosened it and then brought up this end of the scale so that the dial indicator was re-zeroed. So let's go ahead and bring the table back and forth again and see if the scale is indeed level. All right, so you can see as we move the table down to the other end that the dial indicator stayed right at 0. And that means that the scale is perfectly level. Now, I'll be honest with you, we got pretty lucky on that one. And it always doesn't work out that on the second try that you just get the scale level. Most of the time, you're really going to have to go back and forth quite a few times until you get the scale zeroed out. But go ahead, take your time, and get it right. All right, so we went ahead and we showed how to measure the top edge of the scale and make sure that the scale was perfectly level from left to right. But what about the height of each end of the scale, or the face or side of the scale? How do we know that each end is the same height? Well, because we're mounting the scale to the back of the table, which is a perfectly flat machine surface, it's fair to assume the surface is true, and therefore each end or face of the scale is also the same height as the other. Of course, you can always check this with your dial indicator just to make sure, but for us, we're confident the scale is now true. So next, we need to set the distance between the read head and the scale. So we need to go back to the bag of parts we found in the x-axis scale box earlier. Now, inside this bag of parts, there's a clear plastic bag with the scale shim inside of it. Now, remember, it's fairly easy to miss, and here it is. Now, a great technique that we've heard back from our customers is to simply write the word shim on it so it's not quite so easy to lose. And remember, the purpose of the shim is to help set the correct distance or gap between the read head and the scale, which is 0.5 millimeters plus or minus 0.2 millimeters. So let's go ahead and check that out. First, we'll loosen the 6 millimeter read head bracket screws. And then we'll slide the shim between the read head and the scale. Now, one trick to remember here is to leave a little bit of the shim hanging off to the side, and we'll explain more on that in just a few minutes. And basically what you want to do is to extend the grub screws until they just make contact with the side of your machine. Now to make sure you've got it just right, try and rock the reed head bracket assembly back and forth. If the assembly rocks, then you need to readjust the grub screws. So you can see here that the reed head assembly is rocking back and forth just a little bit. So I'll readjust the grub screws. I'll try rocking it again, and now that feels pretty solid. All right, so I'll tighten everything back down. Now, what you're looking for at this point is that the shim is snug, but not absolutely pinned down tight between the reed head and the scale. In general, if you can hold the shim down tightly with your finger and move the reed head off of the shim by turning the hand wheel, then your spacing is right on. If the reed head drags the shim and the finger pressure can't hold the shim in place, you've probably got the gap a little bit too tight. Let's go ahead and check that out. I'll put my finger on top of the shim and then move the table down, and you can see that my finger pressure alone is pulling the shim out. And there it is. So here's the shim, and it looks like the gap is right on. Okay, so at this point the scale and the reed head are installed. So let's go ahead and make one final operational check. What we need to do is to run the table through its full travel. Be especially careful as you approach the ends of the scale. Make sure the reed head doesn't bind or dig into the stainless steel cover. And remember to check all the way to both ends, full travel. Now finally for the last step on our X-axis installation. Now here's the original unaltered scale cover, and the directions with the kit will tell you to mount it above the scale directly to the machine. But we'd like to offer you an easier alternative. We recommend you mount the scale cover directly to the end caps of the scale rather than the machine itself. And if you take a look at the end caps, you can see that each end cap already has a tapped and threaded hole on the side of it. So instead of mounting the cover to the machine and then having to drill and tap more holes, we simply recommend you mount the cover to the end caps of the scale, which saves you from a lot of extra drilling and tapping. So here's the stock cover, and to make this happen, I'm going to have to modify it a little bit. First, I'm going to have to shave off this top tab, and second, because we shorten the scale, I'm also going to have to shorten the cover. All right, so we've completed our cover modifications, and here's the modified cover. Now first, I shaved off the top tab that ran along the edge here, and then I shortened the length of it. Next, I drilled a hole on each end along the side here to match the end cap hole spacing on our shortened or modified X-axis scale. Now one last tip. The end cap side holes by design are not very deep. So if you choose to mount the cover to the side of the scale like we recommend, you can't use the supplied cheese head screws because they're designed to mount the scale to the machine and they'll be too long. So what you can do is either try and shorten them, or what I would recommend is to simply use a lower profile, shorter button head type screw. All right, so let's go ahead and mount the cover. All right, so that completes the installation of the X-axis scale. So let's move on now to installing the Y-axis scale.